Hello, I'm Alexandre, and in this demo, I will be presenting MASPY, a Python framework for developing BDI agents with reinforcement learning. Our motivation for this work was the creation of a framework for developing BDI multi-agent systems fully in Python. In the Python language, few platforms provide the creation of multi-agent systems, and fewer still for a single BDI agent. We found that none can be used to create completely realized BDI multi-agent system with reasoning, communication, environment modeling. And this last aspect is the other motivation of our framework. The Python language helps with seamless integration with machine learning, and our goals were the ease of modeling of custom environments that can be trained and interacted by BDI agents. So, our contributions were the creation of MASPY, a general-purpose BDI multi-agent system framework that has the declarative programming style inspired by agent speak and with integrated environment modeling, which is trained with reinforcement learning. This framework also includes a graphical interface that displays the system information during the execution. This helps the user to monitor the BDI agent's reasoning, their communication, environment interaction, and any learning in real time. For a brief overview of the framework, this image represents how a MASPY system can contain any number of agents, their learning components, communication channels, and environments. Overlooking the system is the admin that is used for configuration and logging. The BDI reasoning that occurs inside each agent is then represented here, where the combination of the environment perceptions, received messages, and learned policies, together with the agent's available beliefs, goals, and plans, turn into actions and messages they execute by their intentions. To show all of this in action, we present a case study of a navigational example. Several agents are placed on a random 2D grid and have the goal to find the target. With all classes working in tandem, the agents use their partial learning to interact with the environment and communicate about found walls, paths, and the target. Let me show you the execution of this example. So I'm going to be showing you some parts of the overall code. This is the configuration, the main part of the example where all the pieces come together. Where I import the map, the agents, and the screens to show you visually. The agent is shown right here, where I do the learning process in the initialization. So you can see here what I make the model and add it to the policy of the agent, and I do a key learning with a set of number of episodes. And the agent has his plans for making the movement when they don't have the target, which uses the best action, or when they know the target, where they use A star algorithm. So let's do it. The first screen here shows that we are going to be doing a 10 by 10 with 20% of walls with 6 agents and 2,000 episodes. This indicates only a partially number of learning episodes, not enough to all agents to know all paths of the map. So at this point, when all agents are ending their learning is when the system is going to be starting. And here we can see the actual movement of the interaction. And so eight agents are moving based on what they know, and when they communicate about the paths, the walls, and when one finds the targets, everyone goes to the target about with using the information that has been communicated between the agents. And this is shown in the console, where you can see in blue how the messages are being sent, how one agent is sending the belief of the target to all others, and they are sending the graphs that they have. They are always communicating between the movements. This screen shows the graphical interface, where we can see here all the intentions of the system, but this is maybe overwhelming. So you can go to each agent and see the beliefs that the agent has, the intention history, the environments that they connected to and the perceptions and the learning itself that they used for their actions. We can also go by environment and see the perceptions, the history of the perceptions. We can see the agents that are connected to it. We can see all the messages that we sent or specific messages from one agent, and all the learning that has been done in this execution. Be sure to send us any questions, but you can find the complete framework in this GitHub link. And thank you very much for watching.